Welcome to a video on sampling. So today we're going to, rather than look at expected probabilities, we're going to look at running a probability using like an experiment. And this is called sampling. So sampling is performing the experiment a number of times and recording the results rather than what we expect to get. So such as tossing a coin, rolling a die, even researchers who do a phone survey. They're all considered types of sampling where you conduct the experiment rather than just rely on what the predicted result is. So in a previous video, we looked at when you toss 5 coins and you count the number of tails. So in those ones, we actually had the probabilities as fractions. So to help us with this and with our survey or doing our experiment, so our sampling, I've changed them to decimals, but the same concept. So the probabilities are still similar. So the first one was probability of getting no tails out of the 5 was 1 in 32, which is approximately 0.031, and etc. for all of them. We get our variance like we did before, 1.246, and we get our standard deviation, which was the square root of 1.246 of 1.12. So now let's look. So using a program, I've actually conducted this experiment 1,000 times and recorded the number of times a tail appeared on the 5 coins that were actually tossed. So no tails appeared 36 times, 1 tail appeared 163, 2 was 316, 3 was 307, 4 was 156, and 5 tails appearing on all 5 coins 22 times. That adds to the 1,000 tosses that were conducted. So therefore, the frequency is for the relative frequency is the frequency divided by the number of times. So 36 divided by 1,000 is 0.036, 163 divided by 1,000, 0.163, etc. across. And so they're our probabilities. And you'll see that they add to 1, just as all of our probabilities have so far. Next one is x times the relative frequency. So similar to what we did before, we take the x, so the score of 0, times it by the probability, or the relative frequency, 0.036, and you get 0. Score of 1 times 0.163 gets you 0.163. Score of 2 times 0.316 is 0.632, etc. for each of them, giving us a sum of x times relative frequency of 2.45. This is our sample mean. So we're going to represent this with an x with a little bar. So the population was mu for the mean. For our sample, it's x with a little bar. And then finally, our last column, to allow us to use the variance formula, is x squared times the relative frequency. So similar, 0 squared times 0.036 is 0. 1 squared times 0.163 is 0.163. 2 squared times 0.316 is 1.264. Continue that across and you get a sum of 7.236, giving us a variance of 7.236 minus the mean squared, which was 2.5, and that squared is 1.2335, giving us, that's our variance, and our standard deviation is the square root of that, which is 1.11. And you'll see that that's fairly close to the solutions that we actually got for the expected values. Thank you.